You know magnets, right? Of course you do. They're on our fridges, they make our electric motors spin, they hold all our data. They're just a fundamental part of our world. And yet, for all that familiarity, magnetism is still hiding some incredibly deep and, frankly, pretty fascinating secrets. And that's the big question, isn't it? We've been using this force for centuries, but when you really zoom in, when you look at the nitty-gritty details, our best theories still have some really puzzling gaps. Today, we're going to dive into a new way of thinking, a new framework that claims it can finally fill them in. So, before we can get to this new idea, we've got to understand the problems it's trying to solve. And these aren't just minor little issues, we're talking about foundational questions that have had physicists scratching their heads for decades. Think of them like four big puzzles just waiting for the right key. What's wild is just how basic these questions are. I mean, what is an electric current? We know how to use it, obviously, but what is it really at the microscopic level? Or why do magnets form these little regions, these domains, that seem to fight each other and waste energy? Why do our super precise experiments keep showing that materials have these tiny built-in directional preferences? And maybe the biggest one, why do our gold standard Maxwell's equations, which are brilliant, sometimes need a little tweak, a little fudge factor, to make them work inside real-world materials? This is where things get really interesting. See, the usual way to solve a physics puzzle is to go looking for a new particle or maybe a new force. But what if the solution isn't about adding something new at all? What if it's about looking at everything we already know through a completely different lens? Okay, so this new lens is called the Harmonic Scale Framework, or HSF for short, and it proposes something pretty radical. It says that everything we can see and measure, particles, fields, forces, the whole shebang, isn't a big collection of different things. Instead, it's all just one total wave that's vibrating in 5 distinct but interconnected harmonic channels. You can almost think of reality as a radio that's playing 5 stations at the exact same time. K1 is the matter station. That's us, that's stuff. K2 is the electromagnetism station. That's where light and magnetism live. K3 is all about how materials organize themselves, kind of the collective vibe. K4 is like a quiet energy storage depot, a battery. And K5 is the very slow background hum of the cosmos itself. But here's the kicker. They're all part of the same broadcast, and they are constantly talking to each other. So, the big question, how does this 5-channel radio model help us with those magnet mysteries we started with? Well, this is where it gets really, really elegant. Because once you see how these different channels interact, those old mysteries start to look less like mysteries and more like simple wave mechanics. Remember that first puzzle, what is an electric current? HSS says it's not just electrons hopping along a wire. It's more like a synchronized wave, a river of phase that's flowing between the matter channel, K1, and the electromagnetic channel, K2, at the same time. It's a dynamic 2-channel phenomenon. Okay, what about those weird magnetic domains? This is so cool. HSF brings in 2 more channels to explain it. It says that the collective channel, K3, is what gets all the atoms to sync up into these big magnetic regions. And the reason they're so stable, even when it seems inefficient, that energy depot channel, K4, acts like a battery, storing just enough energy to help lock them in place. Suddenly, it's a 3-channel dance, and it all makes sense. And those tiny, stubborn directional effects, this might be the most mind-bending answer of all. So get this. HSF proposes that everything exists inside a shared universal boundary. And this boundary isn't a perfect sphere, it's slightly flattened, kind of like the Earth itself. The theory says this subtle, universal shape impresses a tiny geometric fingerprint onto all 5 channels, creating those small but persistent directional quirks that scientists have been measuring for years without knowing why. Now, I know this all sounds like a beautiful story, but is it science? A theory is only as good as its predictions, and the real power of HSF is that it's not just explaining old mysteries. It makes concrete, testable predictions that you can take into a lab to prove it right or prove it wrong. And here are just a few. For instance, it predicts that if you take a magnetic sample and just rotate it, its properties should change in a very specific way that's linked to that universal flattened geometry. It predicts that for some materials, magnetism should depend on the direction a wave is moving, not just its frequency. And get this, it even predicts that there's a tiny hidden energy signature from that K4 channel, that energy depot, buried in the magnetic data we measure every single day. These aren't vague ideas. They are specific instructions for an experiment. So, if those predictions actually hold up, This isn't just a new chapter for physics textbooks. It could be a brand new playbook for engineers. I mean, imagine what we could do if we've been trying to make music with just one knob on the stereo when there have been 5 this whole time. It opens up entirely new technological possibilities. So let's talk about the low-hanging fruit here. The first and most immediate application could be in something we use every single day: magnetic devices. The motors and transformers that basically run our world. HSF suggests they have a massive, hidden potential just waiting to be unlocked. By understanding and actually engineering the coherence of that K3 channel and the energy storage of the K4 channel, HSF suggests we could design magnetic cores for motors and transformers that are 30 to 40% more efficient. That is a massive leap forward. It means less wasted power, lower electricity bills. It's a huge deal. And it doesn't stop with motors. The theory could completely change how we think about data storage. Right now, we often have to fight against those magnetic domains. HSF says, what if we could learn to engineer them with incredible precision instead? And the payoff? The design rules that fall out of HSF could lead to magnetic memory, like our hard drives, that are 10 times more stable, while using only 1/10 of the energy to write new data. That is an absolute game changer for data centers, for your laptop, for everything. And from there, it gets even more futuristic. By engineering how waves travel through a material, using all 5 channels, we could create passive materials that act like super lenses, letting us see things smaller than a wavelength of light. We could make perfect shields for radio waves that don't use any metal. I mean, we're talking about stuff that sounds like it's straight out of science fiction. So, we end up right back where we started with a huge question. The Harmonic Scale Framework offers these elegant answers to old puzzles and a tantalizing roadmap to new technologies. It asks us to see the world not as a collection of separate particles and forces, but as a single, unified wave playing a beautiful 5-part harmony. And if it's right, we may have just found the master control knobs for engineering reality itself.